Hi, welcome to Armor One. Today I want to talk about MCP tool poisoning. So here's how a trusted looking MCP tool can quietly become the attacker's instruction channel. This attack targets the MCP tool interface itself. The attacker hides hostile instructions inside tool metadata, descriptions, schemas, or outputs. The assistant reads that poison content as if it were trustworthy guidance and then acts on it. Invariant Labs documented MCP tool poisoning in April 2025, and CyberArk later showed that poisoning could extend beyond descriptions into schema fields and server outputs more broadly. So a real-world example is that in our documented research, the issue was not just that the tool existed. The real problem was that the assistant trusted what the tool was telling it, even when the content was malicious. That creates a nasty little gap between what the user thinks the tool is doing and what the model is actually being instructed to do. So this is where Armor One could have made a real difference. By helping teams verify the MCP server, understand the risk of the toolpath, and stop unsafe tool use from happening automatically. So first we'll look at Gemini CLI, and we're going to look at MCP server config as our metric. So this matters because before trusting any tool, you need to understand whether the connected server itself is safe to trust. Next, we're going to look at Git MCP server on the MCP server side of things. So what I want to focus on is trust and data flow. This helps show whether the server introduces risky remote paths or unsafe data handling that could turn poison tool content into real downstream action. And the next one is source code visibility, which is here. If a tool or server cannot be properly inspected, then teams are being asked to trust a black box, which is exactly where this kind of attack can get very dangerous. So now we're back at Gemini CLI. I want to talk about MCP server configuration remediation because we went over it. So the first thing we'll press is show. We'll get information about the risk metric as well as the impact. And then for remediation steps, we're going to check the users. We're going to look at Nova. Once we open Nova, we'll get the same thing, but we'll also get steps. So basically, the remediation is to remove the risky MCP servers. We're going to open the Gemini CLI settings file, which are located here. We're going to locate the MCP servers key at the top level, and then from our other page, we can look at any risky MCP servers that Armor One has shown us, and then remove them. After this, we can save the file and restart Gemini CLI. And for all other risk metrics, there are similar remediation steps just like this. So instead of blindly trusting an MCP tool because it looks legitimate on the surface, Armor One helps teams validate the server, inspect the toolpath, and reduce the chance that poison metadata turns into autonomous action.